When we talk about sugar in the diet, the conversation usually revolves around calories, energy, and maybe weight management. But a recent study in Nature Metabolism dives deeper, revealing a fascinating and complex story about how sugar interacts with the body at a microscopic level and why one enzyme, SORD, may hold the keys to understanding cancer progression. Think of SORD as a molecular engine, quietly working in cells to process sugar. Under normal circumstances, it's just a helpful worker in the body's metabolic machinery, converting sugars like fructose and glucose into usable energy. But when cancer cells get involved, this otherwise ordinary enzyme becomes a turbocharged collaborator, turning everyday sugar into fuel that can power cancer cells' growth and spread. To imagine this, picture SORD as the engine in a car. Normally, it runs efficiently, keeps the vehicle moving smoothly, and supports healthy traffic flow in the cellular world. When fructose and glucose from sugary drinks enter the scene, however, it's as if you filled that engine with high-octane fuel. Cancer cells are the drivers with a need for speed. They hijack this engine to accelerate their journey beyond their usual neighborhood, allowing them to metastasize into new areas. What makes this discovery remarkable is the level of detail the researchers provide. Instead of a vague "sugar might be bad," we now understand exactly how SORD interacts with sugars to empower cancer cells, making the invisible mechanics of disease visible and understandable. But here's the hopeful part. Understanding SORD's role also opens doors for intervention. When scientists know that cancer relies on this sugar-powered engine, it becomes possible to imagine strategies to interfere with it. Drugs or therapies could be designed to slow down or regulate SORD, effectively depriving cancer cells of their turbo boost without disrupting normal cell function. This transforms a previously abstract threat into a tangible target, giving both researchers and clinicians new tools to fight cancer more intelligently and selectively. Beyond the lab, this study also gives people a stronger reason to think about their sugar intake, not from a place of fear, but from one of empowerment. Cutting back on sugary beverages, choosing whole fruits over processed juices, or simply moderating added sugars can reduce the fuel available to SORD-driven cancer cells. Small lifestyle changes can have a meaningful impact, turning ordinary daily choices into deliberate acts of cellular defense. Knowledge, in this sense, becomes a form of prevention. By understanding how the enzyme works, we gain control over one of the factors that cancer cells rely on. There's also a broader scientific significance here. This research exemplifies how digging into the molecular details of disease can illuminate new pathways for treatment, prevention, and public health guidance. SORD is not inherently bad. It's a vital part of normal metabolism, but in the context of excess sugar and cancer, it becomes a powerful enabler. That nuance is critical. It reminds us that science isn't just about labeling things good or bad. It's about understanding context, mechanisms, and opportunity. And in this case, the opportunity lies in targeted interventions, informed lifestyle choices, and smarter therapies. So while SORD may sound like a sinister enzyme in headlines, the true takeaway is far more positive. It is a window into how disease operates, a map that shows us where sugar meets cancer, and a roadmap for potential solutions. With this understanding, the narrative shifts from helplessness to action, from mystery to strategy. SORD, the enzyme that turns sugar into cancer fuel, is no longer a hidden threat. It is a revealed mechanism that scientists can study, block, and ultimately use to improve health outcomes. In other words, the more we know about this enzyme, the more we can protect ourselves, transforming what might seem like a dark story into one full of hope, insight, and opportunity.